All right, guys. So we've all glued down our area notes in practice, and we're going to be reviewing the different ways to find area for the first 4 shapes. So square and rectangle should be a review from like 3rd grade, 2nd grade, I don't even know when. A while ago, right? But last week we worked on how to find the area of a triangle and a parallelogram. So let's start with those. And I'm just going to pull up some proofs of some people. We'll start with parallelogram. Let's see if I can find a good proof from AM for parallelogram. Let's see here. Okay, here's one. So I'm going to use Soham, Jesse, Andy, and Dylan's. And what you guys have done was you took your original parallelogram and you duplicated it. They give you 2 congruent parallelograms. What does congruent mean, Orlando? The same size. Perfect. And what you did was you cut out a right triangle. You cut out a right triangle and you moved it over to the other side of the parallelogram to fill it in and create a rectangle. Do we already know how to find the area of a rectangle?
Yeah.
What's that noise? I think it's right. Okay. If we already know how to find the area of a rectangle, can we find the area of parallelogram?
Yeah.
Yes. What is the thing we have to remember when finding the area of a parallelogram versus finding the area of a rectangle?
Like the height, it's not like the angle, it's just straight up.
Perfect. In a rectangle, we do base times height or length times width. This diagonal in a parallelogram does not represent the height of a parallelogram. Instead, you need to look at your base, so your bottom, however your parallelogram sits. And if your paper is like this, if on your homework it's faced this way, guess what? Turn the paper so that you've got a base, okay? You're going to look at that and you're going to do any line that meets the base at a 90-degree angle, and you're going to connect the 2 parallel bases of a parallelogram. That is going to give you your height. So then what's going to be the equation to find the area of a parallelogram? Base times height. Exact same thing as a rectangle. Since we just proved we can turn a parallelogram into a rectangle. Any questions about how to find the area of a parallelogram? Perfect. Now triangle is going to be a little more tricky. Who here got to do the triangle proof? A few people? Okay. We're going to use Ryan, Orlando, and Chandler's. Okay. So what they did, and what you guys should have been able to do, but maybe not everyone got to it, is they had 3 different triangles that were given to them. The first 2 were 2 different congruent triangles, right? And what we did was we duplicated them to create what kind of shape? A square or a square or a rectangle. Do we know how to find the area of a square or a rectangle?
Yes.
Yes, base times height, right? So, if it's base times height, but we only want the area of one of these triangles, what are we going to do after we multiply base times height, Reese?
So you could divide it by 2 and then you get
You're going to divide it by 2. Since you've got 2 congruent triangles to make this square or this rectangle, you're going to do base times height and then divide it by 2. Now the very last triangle, the first 2 were right triangles that were given to you. The last one was not. It was more of an equilateral triangle. Can you still find the area of an equilateral triangle using that same formula?
Yes.
Yes, you can. So if we've got an equilateral triangle, meaning it does not have any right angles, it has 3 acute angles. Your base is still going to be that bottom of the triangle, and remember, you can always turn your paper to make a base. Your height is going to be going from the top vertice opposite from your base. So you want to go from the opposite angle across from your base, and you want to go down at a 90-degree angle to find your height. Then you can still use that same formula. So to find the area of a triangle, you're going to do base times height, and then divide it all by 2. So you can write that a few ways. Area equals base times height divided by 2. Those are 2 different ways to write how to find the area of a triangle. Remember, a fraction bar means division, so it's the exact same process, just written 2 different ways. Any questions for finding the area of a triangle or parallelogram?
No.
Perfect. We're going to pause here. Okay, you're going to have trapezoid notes and your graph paper. You are going to draw on your graph paper a trapezoid. It can be any kind of trapezoid. I just happened to draw an isosceles trapezoid, meaning my 2 diagonals here are equal length. Not all trapezoids are like that, okay? You're going to draw one trapezoid on your graph paper. You're going to cut that trapezoid out. Then you're going to trace the same one again. So we want 2 congruent trapezoids cut out from your graph paper. However big you want, but they're both going to have to fit side by side in this top part of your nose. So not too large, but you want to be able to tell. Okay? So do that now. All right, we're quiet. After you cut out your 2 congruent trapezoids, you want to try to arrange them into a parallelogram. You're going to glue this parallelogram at the top of your trapezoid notes. And I want you to complete number 1 on your notes, where it says, estimate the number of unit squares from 1 trapezoid above. I know it says the trapezoid above, but we're only trying to find the area of 1 trapezoid. I want you to try to estimate how much unit squares there are in 1 of those 2 trapezoids that you just made in the parallelograms. Okay, so now that we have our trapezoids and we've arranged them into a parallelogram, we are going to try to find the area of just one of these trapezoids. So for number 1, you should have kind of estimated. How did you guys choose to estimate?
By finding the answer.
What did you do? Did you count the squares?
Yes. In a way, I was just like
Like
1, 2, 5,
estimating?
7, 9.
Because some of these squares are just pieces of squares, right? So it's like that might be 3/4 of a square, and you might have to estimate. Well, we're not going to estimate anymore. We're going to learn how to find the area of a trapezoid using what we know about finding the area of a parallelogram. How do I find the area of a parallelogram? Area of a parallelogram is equal to what, Sesmita?
A equals B.
Base times height. Remember, base is that the 2 parallel sides, either one could be called base. Height is the perpendicular line that connects the 2 bases. Okay? If we know that, can we manipulate this to represent both of these bases? So notice that in a trapezoid, your bases, hold on, your bases are 2 different lengths. In a parallelogram, your bases are the same length, which is why that works. So here's what we're going to do. My bottom side, or in mine, it's the green side, I'm going to call base 1. I use that little subtext 1, and up here, I call that base 2, with a little subtext of that 2. Because they're both the bases, the height connects them at a perpendicular angle, but they're going to be 2 different measurements. So in the trapezoid that I duplicated and flipped over to make a parallelogram, is this length base 1 length or base 2 length?
Base
base 2 length. And this green part on the top is base 1 or base 2 length. Base 1 length. So, can I manipulate the equation for area of a parallelogram in order to find the area of just one of these trapezoids? Well, let's look at it. Let's take base. Height's going to be the same no matter which trapezoid you're looking at, right? So let's look at our base measurement. If we're trying to find this part of our area equation, how do I find the base measurement for this big parallelogram? What can I do, Krisha? I need a count to find the actual length, but since I have variables there now, can I use the variables to talk about a general equation, an algebraic equation? So what would it be? What's this variable? Base 1. What's this variable? So those are actually two different variables, right? What can I do to these two measurements to find the total base of my parallelogram? Add them. So to find the base of my large parallelogram, I want to do base 1 plus base 2. So if I was to replace this equation into my formula for the area of a parallelogram, that turns into base 1 plus base 2, because we said that's what the base is equal to, right? All of that, after you add them up, you're still going to multiply by the height. The height does not change when I doubled my trapezoid. If I was to do that, base 1 plus base 2 times the height, I'm going to get the area for this entire parallelogram. So what am I going to have to do to that at the end to find the area of just one trapezoid? Divide it by 2. So I'm going to take base 1 plus base 2, multiply by height. That's going to give me the area of the entire large parallelogram. But I want to cut it in half to show the area of just one trapezoid. So divided by 2. Do you think we just found the equation for the area of a trapezoid? Yeah, and we proved it, right? So let's actually try it, okay? Base 1, I already counted, so I know mine is 16. Yours might be different, so you're going to have to count yours, okay? I know my base 1 equals 16. I know my base 2 equals 10. I just already counted, so I already knew. Go ahead and count your bases and your height. What if? So it might look like half. I would not count half because it's going to go kind of, it's just because of the way we glued it. So don't count the fraction pieces because now you can have fractional pieces, but for this purpose, I would not count them because it's just the way that we cut. It's kind of human error for cutting. Yes?
Or should I split it for the height part?
Anywhere where there's a perpendicular line connecting base 1 and base 2 on either of the trapezoids.
Does it have to be understood?
Sit down. Okay, so now we're going to try it out. Now that you got to try it on your paper. So let's look up here at Miss Greathouse's example and make sure that you're following along and understanding the steps that I'm taking. So I'm going to use the formula that we just found for the area of a trapezoid is base 1 plus base 2 times the height. Then I need to divide that all by 2. So base 1 for me is 16. So I'm going to do 16 plus base 2, which is 10. Then my height is 1, 2, 3, 4, 5, 6. So I'm going to multiply those by 6. And after I do that, I'm going to divide that all by 2 so that I can get the area of just one trapezoid. Shh. You guys, stop moving your papers. Okay. What's 16 plus 10? 26. Now I need to do 26 times 6. 6 times 6 is
156.
36. 6 times 2 is
Something.
12. Plus 3 is 15.
Yeah, I was
To
right.
get 156. So what am I going to do? 156 means in this whole parallelogram, I have 156 unit squares. But I only want to find just the trapezoid. So I want to take away that other half. So I'm going to divide it by 2. So I'm going to take 156, divide it by 2. 2 goes into 15 7 times. 14, 1, bring down, 78, and that gets us a remainder of 0. So what is Miss Greathouse's area for her trapezoid?
78 squared.
Units squared. Do not forget your measurement at the end. 78 units squared. If you do not include those measurements and you do not include the squared, it's wrong.
So you'll get
You will get points off. Yep. Okay? If you put just units, that would mean you're talking about a unit of length, a one-dimensional length. But by putting units squared, you're telling your reader, this is area. This is the inside of a shape. How much space is inside of a shape. Okay? Any questions for finding the area of a trapezoid? Good? All right, there are 3 workbook pages up here on the board. These are going to be the 3 different shapes that we've reviewed. Parallelograms, triangles, and trapezoids. I'm going to put the answer keys out. Even though it's not on your game board, you can still earn points from your team, for completing them. So these are going to be great practice to prepare you for your homework. Yes, Reese?
You can use your homework instead.
No, you may not do your homework instead. Yes.
I already finished it.